Friends, in the last video we discussed about classical gravity, and also I told in the last video that in the next video we are going to learn a very interesting topic, that is quantum gravity, and today we are present with it. Quantum gravity is rather a very complex concept, and I must say that we have not found any theory or any perfect statement for quantum gravity because we are only researching on it till today. So we have not found anything rather, and because in this video I am not going to tell you about the theory of quantum gravity, but I am telling you how quantum gravity is useful, why it is very important to study quantum gravity, and what are its uses. So let's go and learn what is quantum gravity. Hey guys, welcome to Bright Brains. This is Girish back with a new video, and today we are going to discuss about quantum gravity. Quantum gravity is a very vast concept, and I will tell you one thing first, okay? So in the classical world we use general theory of relativity given by Sir Albert Einstein to understand or to define what is gravity in classical world. But at some places like the center or the near to the center of black hole, or at the high gravitational field phenomenons like near to a neutron star, there we can't use the general form of relativity or the general theory of relativity to define what is gravity. This happens because there actually two things are very important. First one of which is quantum fluctuations, and the second one is space-time. Space-time can be understood by the general theory of relativity, but to understand the quantum fluctuations, it's very important to take a new branch of physics, and which is nothing but the quantum gravity. If we understood about the quantum gravity, or if we find some equations about the quantum gravity, or we find a theory on quantum gravity, we can basically answer many questions like how the center of black hole works, or what is the mechanism of the center of black hole. We can also learn about neutron stars or the high gravitational fields, and we can learn about how gravity works at a very quantum level, at the particles level. Now some people must ask that why can't we use classical laws of gravity or the classical mechanics there on the quantum world. So physics exists in two parts. The first one is the macroscopic and the second one is microscopic. In the macroscopic world, physics divides it into classical mechanics. Physics use it classical mechanics in that macroscopic world. And here in the quantum world, we need to use the quantum physics or the quantum mechanics. So these are the two partitions of physics, and we have not rather yet found any relation or any connection between the both the theories or both the parts of the physics world. And the day we will find it, we will make a very important discovery in physics, that is, we will find the TOE is nothing but the theory of everything. So now let's come back to the topic of quantum gravity. Quantum gravity does not takes each and every field like now I told you about the theory of everything. It will take each and every field of physics and combine them and find the equations for them and make a new field. But rather, quantum gravity is a theory of quantum mechanics and gravity. It will just take these both concepts and make quantum gravity. It will only study about how gravity works in the quantum world and nothing rather than this. It will not go under any of the fields, or it will not study how gravity works in this field or that field. It will only see how gravity fluctuates with the quantum objects. Now basically the problem arises at a very small scales, like the quantum gravitational field. We can't study it fully, or what experiments we do on it, we can't do that because it exists at a very small scale, that is the Planck scale, which is almost in the meters. If I want to tell you, it's 10 raised to the power minus 35 meters, and it's very small. and because of this, whatever experiments we do on it, we are unable to test it, or we are unable to get any outcome of that. And with today's particle accelerators, with today's technology, we rather can't do that, if I will tell you. So this is the problem, that we have not found any connection yet in the quantum mechanics and between gravity. And so we are only studying about quantum gravity. As in the starting of the video, I told you that we have not found any perfect theory of quantum gravity, but rather we are studying. And one day we will surely find it, or I will surely try to find it one day. So till that, keep watching Bright Brains and keep exploring.